In our lesson today, which is over section 4.4, day 2 over complex numbers, we are going to continue in our notes, which if you were in class, you already completed the top part of this handout. If you weren't in class, this handout can be found on my Canvas page. So I'm going to move down here, and the imaginary unit I led to the creation of what are called complex numbers, which have both a real and an imaginary part. A complex number written in standard form is of the form a plus bi, where both a and b are real numbers. The real part of the complex number is a, and the imaginary part is bi. Some examples of complex numbers would be 1 plus 3i, or 5, or -4 minus I, or 2i. Now, keep in mind that the number 5 is just showing that you have a real part and the value of b for the imaginary part is 0. Likewise, 2i means that the real part is 0 and the imaginary part is 2i. So those are examples of complex numbers, and we are going to be able to add, subtract, multiply, or divide complex numbers. And to add or subtract them, we're going to treat them like algebraic expressions. We're going to add their real parts, we're going to add or subtract their imaginary parts. To multiply two complex numbers, we're going to either use the distributive property or FOIL. You'll see in our examples. All answers must be written in complex form a plus bi when we're finished. So that's how you want to state your final answer. So let's try some problems if we slide down here. So the first example we have is the complex number 3 plus 5i plus the complex number 2 minus 4i. And what I want you to do is just treat these like algebraic expressions, rewrite the expression without parentheses, and then you're going to combine real parts. So the 3 plus 2 gives you 5. And you're going to combine imaginary parts. A positive 4i and a negative 4i give you a positive I, kind of like positive 5x and negative 4x. So, number 2, subtracting two complex numbers. Again, treat it like an algebraic expression. Rewrite the expression without parentheses. So I'm going to take my first complex number, 4 minus 6i, and when I'm subtracting, like subtracting an algebraic expression, it's like adding the opposite, and I'm going to write minus 3 plus 2i. Then I'm going to combine the real parts, 4 minus 3, which is 1, and then the imaginary parts, negative 6i plus 2i, would be negative 4i. Number 3, I'm distributing here 3i, and I take 3i times 9, and that gives me 27i. And then the 3i times the negative I becomes a negative 3i squared. Of course, we have to keep in mind that I squared is really negative 1. So that really means that we have a positive 3. And what we're looking for is to have our final answer in complex form. So that would be 3 plus 27i. We want the real part first. Something you should understand here about numbers that have a power greater than I to the first. You can't leave any power of I greater than 1, so you need to use I squared to help you break it down. So if you ever have something like negative 3i squared, that's always going to become the opposite of the coefficient because you're multiplying by a negative 1. Likewise, if you have something like positive 11i squared, when you multiply by negative 1, that gives you negative 11. So it's a good shortcut to realize these things because that's going to save you some work if you understand that all I squared's going to do is change the sign of the coefficient. All right, let's continue. In the next problem, we are taking 5i times negative 2. That would be negative 10i. And then 5i times a positive I would be positive 5i squared. Of course, using my little shortcut, that means the 5i squared is really negative 5i minus the 10i. Now we get down to the product of two binomials, and we just use FOIL. So 7 times negative 1 gives you negative 7. Then the outside product would be positive 14i. The inside product would be positive 4i. And then the last product would be negative 8i squared. So I really know I have a negative 7. The plus 14i plus 4i would give me positive 18i. And the negative 8i squared is really a positive 8. So in complex form, when I combine negative 7 and positive 8, I end up with 1 plus 18i. How about the next one? The quantity 6 plus 3i times the quantity 6 minus 3i, that's the product of a sum and difference pattern. Now, I can write all four terms out, but I know the outside product of negative 18i and the inside product of positive 18i will cancel. So I need to recognize this pattern and understand that's what's going to happen. And so really all I need to do is multiply the first terms, the first product, 6 times 6 is 36, and the last product, the positive 3i and the negative 3i, which is negative 9i squared. Can you write all four terms? Absolutely, if you want to, but that's something that we want to recognize when we take the product of a sum and difference pattern, that the outside product and inside product will cancel. At this point, I need to understand the negative 9i squared is really a positive 9, and so this product gives me 45. How about when we divide two complex numbers? So the first thing you have to understand here is that the I in the denominator is really the square root of negative 1. The reason that's important is because that means we have a radical in the denominator of a fraction. So what we need to do is we need to rationalize by using the conjugate since the denominator is a binomial. So the conjugate of 1 minus 2i is 1 plus 2i. Remember, if the denominator, the binomial, is a difference, the conjugate is a sum. If the denominator was a sum, the conjugate would be a difference of the two terms. So I'm going to multiply both the numerator and denominator of my fraction by 1 plus 2i. And remember, I'm going to need to do FOIL here in both the numerator and denominator. And so what I'm going to end up with in the numerator when I take my product is 5 for the first product, then plus 10i for the outside product, plus 3i for the inside product, and then plus 6i squared. That's all over. In the denominator, this really reflects what we saw in number 6. We are taking the product of a sum and difference pattern, which means the outside and inside products will cancel. I can write them if I want, but I'm not, because I know that's what's going to happen. That's why I'm using the conjugate. So the first product's the 1, and the last product is minus 4i squared. So now I want to simplify, and I'm going to go down here. In the numerator, I'm going to have 5 plus 13i minus 6. That's going to be all over 1 plus 4. And then at this point, the positive 5 and the negative 6 become negative 1 plus 13i. And that's all going to be over 5. Now, to really be expressed in complex form, we have to break up the real part from the imaginary part, and this would be written as negative 1/5 plus 13/5 times I. You might think that's an unnecessary step. However, if you're going to be expressed in complex form, you want to write it that way, because that shows the form a plus bi. All right, last problem. When you have number 8, I raised to a power like 15, we saw the other day, because 15 is odd, we're going to break the I to the 15th into I to the 14th times an extra factor of I. We're peeling off that odd extra factor of I so that the exponent is divisible by 2. That way we can rewrite I to the 14th as a power of I squared, which we know is negative 1. So that means we have I squared raised to the 7th, so that's really negative 1 raised to the 7th times the extra factor of I. And because 7 factors of negative 1 being multiplied together will be negative, that means I really have a negative 1 times I, or negative I. All right, that concludes this part of our lesson. The assignment can be found in Canvas. You are going to be working on page 250, continuing in the problems. You also will have a little review. The assignment's already listed in Canvas. And if you have any questions, feel free to email me. Period 5 students, you may have thought we were going to quiz today, but I changed my mind and decided we would finish working with complex numbers. We'll actually carry that over a little more until next time, and then we'll quiz after we return from break. All right, have a great day. Hope this goes well for you.